Good morning, and today we are going to start with MLFlow. So the things that we discussed: Python, ML code. Here we are basically talking about pipelines. This is the important concept that we have discussed. With respect to the deployment stages we are speaking of. So these are all the new things that we have learned. So Python code, in that we need to speak about pipelines. Then we talked about Flask. This is for web UI. Then we discussed about containers. And here we discussed about Docker and Docker images. Then we discussed about Kubernetes. Right, so these are the different things that we discussed. And post that, we talked about Kubeflow. Kubeflow has its own, I should say, constraints with respect to the implementation in day-to-day scenarios. If you have to use Kubeflow, then there is a lot of setup-related challenges that we will have to work through. It's still naive at naive stages. It requires to mature a lot, though people have started using it because of its open source nature, and right, it's basically compatible with GCP. But as we have seen, it has its own challenges, right? So that's something that we have to understand. Kubeflow is a little tricky one, but we also have alternatives to Kubeflow. Right? Couple of the alternatives that we will be discussing are MLFlow and TFX. All right, so these are the two things that we will be discussing. MLFlow is something that we are going to start now. So when we talk about Kubeflow or MLFlow or TFX, the primary agenda of these tools or packages or frameworks, you can say, are basically to ensure that end-to-end ML workflow can be implemented. We are talking about ML workflow. That means the process that we need to follow while developing the machine learning models is to be standardized. Right? That's the idea of these tools. Kubeflow, of course, has an additional capability that it can also manage the hardware. Right? It works with Kubernetes, but it ensures that the auto-scaling capability of Kubernetes is used whenever, wherever it is required in the machine learning phases. Now let us talk about MLFlow. MLFlow, machine learning flow. Again, this is also designed to ensure that we follow crisp MLQ methodology and try and design, develop, train, tune, and deploy a machine learning model. Now, when we talk about your machine learning model, I can broadly split that into train and deploy. At a high level, the very, very high level, we are splitting it at train and deploy. So this is where we will be doing a lot of experimentation. And once we get the best model, that best model has to be productionized. But that means here we will have a lot of iterations, a lot of rigmarole happens with respect to data, with respect to the parameters, with respect to your model selection itself, machine learning model itself. Now, for example, you take some data. This is a sample data which is given to your given by your business for your development. I mean, for your team, so that you can develop machine learning models. So this is some data that you received. What you do? You clean the data. Then you basically arrange or organize the data. You can say both these two steps are combined. And post that, you develop machine learning model. Train. Here, at this step, you basically split the data into train, test, or train, validation, and test. And then here you're training your model. And then you evaluate, you tune. Right? This is a cyclic process that happens. And once this is done, you get the best model. Right? So this is the pipeline, ML pipeline. We call it as ML pipeline. Machine learning pipeline. Okay. Now, what all things are iterative here? What all things are repetitive in this case? Yeah, in this phase, in this flow, what are the various things which are repetitive? Yeah, friends. Naveen, Vijay.
Training.
Training, okay, let me mark that. This is repetitive, okay.
So are you talking about the whole end-to-end cycle or just this?
Yeah, I'm talking about the end-to-end cycle. These are all independent stages, right, Vijay? Everything can be independently performed. So out of all these different phases or steps, which of them are repetitive?
The tuning would also be repetitive because we have to tune it a number of times.
Yes, that's basically training only. Because of tuning, we are changing the training, right? We're redoing the training.
And the data processing also, pre-processing.
Hyperparameter tuning or optimization. This is something which is repeating. Okay, and you're saying data pre-processing.
Yeah.
Data pre-processing will not be repetitive, right? How is it repetitive? We're not changing the strategies, right? You're not changing. Let's say, for example, missing data is there. You're not repeatedly trying out the missing values, right? You're not saying that, okay, this time I'll run mean imputation, next time I'll run median imputation, next time I'll apply regression-based imputation. We're not changing those things, isn't it? That's not repetitive. But for hyperparameters, we keep repeating, say, parameter 1, value 1, parameter 1, value 2, so on and so forth. And we rerun the model. We change that, rerun the model. So rather than data pre-processing, we can say it's about the data ingestion, which is a continuous process. It is not a repetitive process, but it is a continuous process. And as the new data comes in, the steps will go through. Each and every step, we will be ensuring that it is applied onto your new data that is coming. So it is not a repetitive, it is a continuous job. Getting the difference from where I'm speaking?
Yeah, sure.
Yeah. Okay. Next, hyperparameter optimization is fine, but even before hyperparameter optimization, the machine learning models that we are going to select, we are going to repeat the training using multiple different models, right? So this is also something that we will be repeating. So ultimately, it is the training process which is repeated multiple times to get the best result, isn't it? Now, every time you execute a model, for example, ML1, you get certain results. ML2, you'll get, let's say, results 1, result 2. For ML1, again, you are going to alter the parameters. So you also want to record parameter set. Right? And what is the model? You might want to see the configuration. What libraries are there, versions of those libraries. So there are a lot of artifacts that you might want to capture. We call it as artifacts, the entire data and metadata. Okay. So on and so forth. You will be doing multiple such models. If you go to automated methods, there are hundreds of experiments which are done in your automated cloud-based tools, machine learning tools. Now, if you keep running it manually, how would you be able to track which model is the best model? Which of these is the best model? We'll not know, right? Unless until we keep everything in a proper place where we will be able to ensure that it can be compared and all that. We'll not be able to actually compare them if you don't capture the data or metadata and compare it. That give a provision to compare it, isn't it? So that's one thing. Now, once the best model is selected, you need to take that best model and ensure that you package it so that it can be deployed on any system. So it has to be independent. It has to be isolated. Isolated or independent are almost same. Let me not write isolated. I've already mentioned independent. So portable. That means I should be able to implement that model on any system. Secure, modular, so on and so forth. Different features will come into the picture that we need to consider when we talk about the best model. So we need to ensure that it is packaged together like an image so that the best model can be repeatedly used. It has to be repeatably used. Right? So these are some of the aspects that we need to look at. Now, MLFlow is specifically designed to track and maintain the entire ML workflow details, including the data. All right. So this MLFlow is basically used to track and maintain or monitor your entire machine learning workflow end to end. That's the tool. And the beauty of MLFlow is it's an open source platform and it has 4 modules. Your entire MLFlow is being segregated into 4 modules. Tracking is the first module. Right? This is where you'll do experiment. So it's basically a UI. You'll get a UI. You will be able to see all the different iterative executions that are happening. Then we have projects. This will ensure that your best model can be rerun, reproducible. That means when you are getting results, the same results should come again and again when you are trying to use that same model on the same data. It should not change. Reproducible results should be there. Right? And it basically allows us to run the model multiple times. So you can basically say that, okay, this is the best model that we are identifying from multiple experiments. We will basically take project which is giving us the good result. And that result is evaluated so that it is reproducible in different scenarios. This is basically to ensure that you don't have skewness in the machine learning model in the training phase and in the testing phase or in your production phase. The behavior should not change, right? The results should be consistent. Now, once the best model is detected here, you will package it using model surface. You're going to basically package it. Package means you're creating an image, for example, and that would be used for deployment. This phase is for deployment. This is a registry, which is like your pypi.org. Or if yesterday or even before Docker, when we talked about Docker Hub. These are repositories, right? Where GitHub, for example, where you basically dump your code and change management is done using these tools. So Docker registry is a repository where we are going to record the models. It's also used for model management. This is fairly new feature within respect to your MLFlow. It basically records the best model and then captures all the artifacts that are required, metadata that is required with respect to that machine learning model which is getting selected. This will ensure we will be able to capture the model drift, right? So for example, new data is coming in, you're retraining it, and you found the best model on the new data, you'll again register it. But in the registry, you also have model 1. So you can quickly compare model 1 and model 2 and see what are the changes that have been brought in into this new model. Right? So that's basically your model registry. So very, very simple concepts. We are trying to we basically MLFlow is trying to automatically manage the machine learning life cycle phases. And it also allows us the UI, it gives you a provision which will allow us to track or maintain basically your machine learning model, which allows us to understand the data drift. It allows us to compare the metrics, the logs can be captured, the parameters. It basically, right, is using this metadata and data to do all this comparison. It will allow us to do model drift also because it is platform which is capturing all the data and metadata, right? And once the best model is defined, it is also allowing us to deploy the model so that it is repeatable, reproducible, or repeatable. I should be able to use the same model multiple times. Okay, so that's the overall objective of machine learning model. It supports many languages, Python, R, Java, Scala, and all that, right? And MLFlow is developed by an organization called Databricks. Okay, Databricks. Databricks is an organization which is maintaining the Spark's open source community platform. Apache Spark is an open source platform, right? So Docker is basically managing that Apache channel, or you can say that platform. The idea is to ensure that for any machine learning model, you should try and ensure that continuous training capability is provided. And that is the reason why we have pipelines. Right? The pipelines concept coming into picture. So that's the reason why MLFlow has been developed. And you talk about any machine learning model, you basically have raw data coming into the picture. Then data engineers capture the data and allow the data preparation phase to take to perform. And once the data is ready, the data scientists or machine learning engineers come into the picture for performing the training in order to extract meaningful information. This is basically a mathematical expression that we try to bring in. Once the model is designed, that model will be deployed. But the same model may not satisfy the new data that is coming in. That means the new data might have a different pattern altogether. So what happens when new data comes in, we repeat the cycle. Right? So we will not have a fixed hard-coded mathematical equation, but we will have the flow fixed. That means when new data comes in, the new data goes through all this and gives us the deployed solution. Okay, so that's about your MLFlow, friends. The beauty of MLFlow is very simple API-based model. So you'll not have any huge implementations and all that. Okay, these are all different features that your machine learning MLFlow basically provides. API first philosophy, It simply gives you a UI where it will capture all the libraries, the dependencies, the languages. It supports multiple languages. It allows you to reproduce the runs, experiments. It logs models. It is basically allowing us to do the deployment or development in the first phase in different independent modular models. So each stage is assumed to be an independent stage. Right, so that's the advantage which MLFlow is developed on, because if you want to do certain things within the MLFlow features, you can directly use those features. You don't need to use this as an end-to-end product. And a very simple UI is provided. Very simple. This UI is very similar to what we have seen on AWS SageMaker, or you can say Azure Workstation. More similar to Azure Workstation, right? That ML Studio that we're talking about. It's an open source, by the way. Okay, so these are some of the advantages. So it has distinct components, 4 components: tracking, projects, models, and model registry. Yeah, so this is MLFlow features. It's an open source machine learning platform. It works with all the popular libraries and languages which are used for machine learning development. It can be run anywhere. You don't need to have cloud platforms, hardware independent. This platform is hardware, this tool is hardware independent and very easy to set up. All you have to do is pip install. That's all. But when you're doing pip install, it is always recommended that you create a separate environment so that what do you call your dependencies with respect to other codes or other programs with machine learning model libraries does not break. The functionality might break if you use the same environment. Because when you do pip install MLFlow, it tries to brings in all the dependent libraries, machine learning libraries that it is designed to work with. So certain functionalities will work in certain versions. So that is internally checked. So yeah, we need to create a separate environment, virtual environment or separate environment. And within that environment, we will have MLFlow so that your other programs are not getting disturbed. Okay, so that is basically your MLFlow introduction. The key concepts, we will always use parameters based inputs. And when we talk about parameters for your model, right, your ML function, it is always a key and value pair format that we are going to use. And key value inputs will be given to our code. Then we will have metrics. Metrics basically are nothing but your results that you're going to get. And it supports numeric metrics for now. We'll also be able to give notes and tags. This is for your understanding, comments, you can say. Description, custom description that you want to give for your executions or for your models, whatever you're creating, right? We can tag certain information to that. Artifacts is nothing but the model, the data, the various pickle files, the configuration files, right? All those things that we are going to use. All of them are also automatically captured. And then it also says what is the source code that is run. So it is also documenting. And so that's about your MLFlow tracking.
Hey, Sharath, one quick question. So,
yeah,
what do you exactly mean by parameters? Key value inputs to your code means, can you show any example regarding that?
We'll do that example, Naveen. We are going to run through the entire MLFlow using an example. I'll show the UI and all.
Okay.
Parameters,
So,
right? Basically, when you talk about any machine learning model, we try to alter the parameters, isn't it? Different models, based on what
you
model
mean the
you're
machine learning parameters? like different parameters that we give to a particular model, right? So are those the parameters
Yes,
you're referring, or?
yes,
Okay.
yes, yes. So any machine learning model, if I want to do iterative experiments, then I need to change the parameters, hyperparameters, isn't it? So those are basically passed in as key and value pair input. So we will have one parameter, and for that parameter, you will have multiple values in a dictionary form. So these are all the things which MLflow records. And we will be able to see those using the UI. And these are the terminologies as well. You can see which code is running. For every code, we can have a version. If you're running it for the first time, say, for example, you say version 1. If you're running it multiple times, and every time you're running the model, it gets automatically, the version gets upgraded, incremented, right? Auto increment, version 2, version 3, so on and so forth. So that the tracking is easy. Okay, like this, run 1, run 2, run 3, that.
So are the pipelines that we are constructing programmable, meaning like unlike GUI, so in SageMaker we have an AutoML GUI interface, right? So is that the same thing, or is it like we need to invoke something in the code in order to connect the dots between the pipelines?
No, it is like your machine learning model. You develop it, you use certain code within that. It's like packaging those, like Flask application, for example. You have machine learning model, and then you wrap it up using the Flask render template code, right? Then when you run it, the entire script executes. Same way for MLflow, in order to capture the artifacts, we use certain functionalities, MLflow functionalities. Hold on, I'll show you the code. That makes more sense. When you see the code, it makes more sense.
Okay, thank you.
So when you try to develop a model, these are the high-level steps that we do. High level, I'm not going into the details. So we load the data, right? We try to do feature engineering, or data pre-processing, you can say. Then you do the model training. Then you try to evaluate by capturing the metrics. Then you print, and then you save the model, best model. Right? So data, then pre-processing. Once the data is ready, model training, model validation or evaluation, you can say. And these are cyclic steps, of course. Then we are going to push the data, right, for deployment, save the model. These are high-level steps. Here, we are not using any MLflow. Now, if I use MLflow, then we are trying to package it. Okay, and for every model, I mean, if you are using it, you're using for loop right here. For every metric that we are building, for every parameter that we are passing, we want to execute the model and then capture the results, metrics. This is by doing, this is done using for loop manually. Now, if I use machine flow, MLflow, loading the data set, then feature engineering or data pre-processing, you can say. You can see the steps with respect to MLflow. We have imported MLflow, right? And this is your training. Then we are measuring the metrics, evaluation. But look at this. This is MLflow start. This is where you are going to trigger your model. So there is no for loop. We are just first defining our code, right? We are just passing the parameters. But when you do here, when you look at here, The MLFlow is automatically trying to run or log the parameters and the metrics that you have along with the model. So this is the model. These are the results for every iteration, and this is your parameters, different parameters that we try to record. So it is automatically logging the details. You need to initiate the MLFlow cycle. Right? Internally, it is taking care of all the parameters, hyperparameter, right, tuning, and then re-executing the code. And once it re-executes, all the things are captured. So you can see here, the image is very small. Each entry that you're seeing here is like your execution, and you're recording all the details like this. Okay. That's your tracking. It tracks all these things. Track parameters, metrics, artifacts, output files, code versions, right? All these things. This is the UI, MLFlow UI. You'll also be able to look into the graphs and all that additional information as well. This is to start. And this is auto logging. Auto logging means everything is getting automatically captured. If you want specific things to be captured, then you don't use auto log. You use the previous command like log metrics, log parameters, log model, right? So those commands will be used. Auto logging means automatically everything will get logged. And once it is done, you will be able to see the data like this. You will have data that is used, the ML model that is used. You'll also have requirements file. You'll have configuration file, right? You probably will have pickle file if you're using pickle file. So everything that we basically use is available here in the folder. Right, so this is how your MLFlow captures the details. So tracking server captures parameters, metrics. See, parameters are like your input. When you give different types of inputs, your results will change. Metric is the result that you're getting. Artifact means is the entire code and data, everything. Metadata is the information about what were the inputs, how many inputs were passed, when it was passed, what was the result, where is it getting recorded, right? That metadata information. And then models is basically the best model that is chosen, or the models that we are going to execute. Now, the thing is, if you look at this architecture, the architecture basically says that, okay, this is the user interface. Okay, let's say this is user interface, user server. This is the server, MLFlow server, tracking server. But for this front end UI, you need some backend, right? So these are different layers that we will have to look at. Let me show how these things work. The MLFlow tracking server can have different setup or different design. The metadata will always be stored in SQLite database, or it can be in local directories, folders. I'll probably use folders. So either database or folders where you can dump the content. The artifacts, this is your metadata. This is the artifacts. Artifacts is nothing but your code, data, everything that is getting generated or that is being used here. This one will be always be placed in folders. Okay, so these are the two things that we basically try to say in the MLFlow tracking server. So for the metadata, either you use database or local folders. when you're running it on local, everything will be in local folders only. We don't use any SQLite. I mean, it creates, but it's automatically done basically. You don't try to push it, but you can also try and save the metadata into your local directories. By default, we will get database created, folders created, ML runs folder will be created, right? All these things will be automatically done when you're running it on local machine. You can also change the flow, right? This is basically your flow. You can see everything is in our local machine. This is localhost. So everything is in single machine. If you have, let's say, a scenario where you want to use database, so you can use database here. So the difference here is the file store and local artifact repository. Both of them are folders. File store is nothing but folders. If you want to use database, then you can try and use database here for Metastore, and local artifact repository is your folders, right? So this is one, this is two. Carefully observe the difference. Here you'll have files. Both are in the same representation. Both of them are files in local folders. Here you'll have files and the database. This scenario can also be implemented in a server, different location, right? It does not need to be in our local machine. So over the HTTP, that is over internet, we will be able to work with your tracking server, right? So again, the same logic will go. Here you can see SQL database and folders. So you have a local host, and then you'll have a tracking server where you have file store, local artifacts, and the communication with respect to your UI or your code and all that. This is your code, right? This is your code. So this is happening through UI, REST API calls. The database, the folders are that is your local artifact repository. All these things can be placed in different systems, right? So this is something again you can play around with. This is your architecture. Depending on what hardware resources you are using, you'll be able to play around with these settings. Okay, but yeah, these are the different things that we will be dealing with. So metadata. You can have local file system, that is file store. It will create a folder called ML runs directory. This by default it creates. You can also use SQL store. The good thing is it also supports production level database softwares as well. Predominantly SQLite is used because it is, of course, light version. We can also use the plugin schemas. It again internally tries to store. We can also have customized Metastore databases that can be figured out. If you're running it on Databricks, then it has other features also. You can also use cloud-based database services. Okay, so these are all different things that can be supported for your metadata storage. Whereas artifact store, when we speak about, it is folders basically. Right? It could be a local folder, it could be a S3 bucket, or any of your cloud platform storage related things. DBFS is again the directory or file store or folder structure on Databricks. So this is Databricks file system. You can say Databricks file store. So these are nothing but folders. This is either folders or database software. Right, so that's basically your MLFlow tracking server. These are some of the examples on how we can try and store your data. But you can skip this. This is not. You can probably look at it at a later stage. Artifact store. These are all your different folders. And if you talk about Metastore, this is the abstract store. Metastore basically. It generally uses your data stores, or you can also use folders. But here it is only folders. Right, so this is basically how your MLFlow works. These are various Python APIs that we have. These are all readily available codes, you can say, which are supported by MLFlow. Naveen, you have a question?
Hey Sharath, I had a couple of questions. Like one you mentioned about reproducibility, right?
Sorry?
So
one you have mentioned about?
Reproducibility, right? And the
Yeah,
second,
reproducibility. Yes.
so in case of non-deterministic algorithm, so is that feasible? Like we cannot get same results on multiple runs, right? So in machine learning models.
See,
So
once you have the weights, see, non-deterministic models basically means when you are doing iterative works, it is going to give different results. But for example, neural network, once you define what is the best model, you're going to save it, right? Best model means it's nothing but you're identifying some weights. So once the weights are finalized, it is a fixed model, isn't it? It can be repeatedly used again and again. Same results will be there. But if you're saying that in the first execution and second execution, I should say, get the same results, then no, non-deterministic models will not give these same results in these multiple executions.
so how can we ensure the reproducibility there in that case?
No, what if, see, I will run neural network multiple times. I'm not getting same results. These are multiple runs. I will run 100 times, for example, 100 execution. Out of all this, which model is giving us best results? Say, for example, somewhere here, it basically says 75. 75th run is giving us the best results. Now, MLFlow is tracking all the details of these 100 executions. So when I look at the 75th run, I will know what are the results, what are the parameters which are used. I will know what is the model. That means the weights, W1, W2, W3, so on and so forth. I will use this best model for deployment. Now, this model will be fixed, right? Weights are fixed, so it will not change. I will be able to reproduce the same results if I use this model, 75th model.
Yeah, got you. Yes, sir.
Making sense? Okay.
Yes.
Yeah, MLFlow is the library. We just dump everything. But if you want to use specific functionalities, you can use these functionalities as well. You can see MLFlow SageMaker is also there. MLFlow SKLearn. This is something that we use. Right, and different other things are there. MLFlow is directly used by Azure. Azure Cloud is following MLFlow only. So for example, if you talk about machine learning workstation, the studio that we have used, internally it uses MLFlow only. Okay, so we will also redo that. We'll try and use notebooks, and I'll show how MLFlow comes into the picture when I'm using Azure platform. These are all readily available built-in machine learning models. We can try and readily use that. The latest of the information is getting updated in your official documentation of MLFlow. This is from official documentation only, but some time back. So you might want to relook at if there are some additional model flavors or models are added here. Okay, and you can simply follow the documentation to try and develop your machine learning models. So localhost, these are the default settings, and these you can see for every ML run execution, you will get one single folder created. And within that, we will have different files and different subfolders. And depending on what kind of model we are developing, what kind of artifacts, metrics, right, what kind of data we are trying to capture using MLFlow, you'll have different content in the folder. Every run, you'll have a unique ID like this. Alphanumeric unique ID will be created. Right? You can see parameters, metrics. This is your artifacts. Then you have tags. If you have given any tags, you'll also be able to see the tags. Right? So all these things will get captured. If you're running with localhost with database, SQL Alchemy database in the backend, then you need to try and connect to your URL. That's your database to record your metastore information. The red color box you can see is basically defining our local store. Okay, so these are different architectural designs that we have. Anyways, this is something that we can.
Shall I the basic question?
Yeah.
Yeah, you talked about those different models or the runs that we are maintaining a record of, or MLFlow is maintaining a record of, right? And after that, we select the best model and deploy it.
Yes.
What is the need of keeping a repository of all the other models which are not being used, or the not so best models?
See, application. When you say best model, how are you defining the best model? On what basis you are defining?
No, once we have defined the best model and we have deployed it.
So if you want to compare it with, again, after a few days, you might want to compare it again.
After a few days, what changes is, say, a new data has come in. So anyhow, the pipeline will be run again and everything will be done from start itself. Then another repository will be created and then another best model will be selected. So is it a standard practice to keep all the versioning? And
yes, yes, it keeps everything. So let me show you. Let's say this is data 1. This is the first time we are developing the models. So I'll have parameter 1, value 1, parameter 2, value 10, parameter 3, value 5. This gives me metrics, metric 1, metric 2, metric 3, some values, performance. These are like your accuracy measures, right? So this is one model that I have selected as the best model when I'm working on data version 1. After a few days, data version 2 came, new data come. Now, when I followed this entire flow, I observed that the best model is model 5, parameter 2 was model 2, value 2, parameter 3 was value 1, metric 1, metric 2, metric 3. Now you can see the parameters have changed, the values have changed for this model with this model when the data changed. Now you might want to, or your management might want to ask you, hey, what was the metrics or what was the performance of this model when I used same values on this new data? Or what was the result on the data 1 version when I was using these parameters here? Comparison, right? You don't know how you might want to compare, or your management want to compare. So if you have data, you will be able to do it. But if you don't have data, you'll not be able to do it. So if you want to do it, fine, do it. But at least that provision should be available, right?
yeah, got it. Thanks.
Right. And see, practically, we may say that this model is giving us best results because of accuracy. Let's say 92% accuracy is there. And it has some parameter. Because of that parameter, we are getting 92%. But when I want to practically use it, apply that in real world, the scenario could be in such a way that the business cannot accept this value. Though machine learning model says value 10 is giving us good results, but practically speaking, the business may not accept value 10 because of various constraints. In such case, what will you do? You cannot choose this model as the best model and deploy it, right? Because practically it is not applied or acceptable. So in such cases, you might want to go for other models which are acceptable. Based on the business conditions, you might want to see what parameters are to be considered, and in those parameters, constraints, given those parameters, which model is giving us good results. Not always go with respect to the metrics-based decisions. Right? Application is different from your model performance. So practically speaking, we never know which one we will choose as the best model for deployment. So from that perspective, everything is captured. And it hardly takes any storage space. Why you want to ignore the possibilities of all these right, various, I should say, research-based choices that we can select, right? Those options are getting diminished if you're not selecting the data. So why you want to lose that opportunity? Right? So from that perspective, everything is getting stored.
Sharath, will when you speak about management here, so will they be deciding what parameters that data scientists will? They only care about
No,
results,
no,
right?
this is no. Data scientists will do that.
Yes. So
Given
how
the
can
set of parameters, which one is better?
okay, but you mentioned that there might be a scenario where management might not can object using those parameters, right?
Yeah,
So
obviously. So as a data scientist, you will know that, right? When you discuss with your management, you'll know that, hey, these are the set of parameters I cannot apply because practically speaking, those are not allowed. So you are going to define the parameters in such a way that those parameters are not there in the first place. You'll have the control, right, as a developer.
okay.
See, when we say model management, it's basically internally capturing the details. And that will allow you to manually evaluate which model you want to choose, which model you not want to choose, which is better, which is not better, how much time did they take to run with one experiment, what experiment parameters we have passed, what was the result on that parameters. All that data is available so that you will be able to do better management. Okay, that's all. It's not like automatically it is doing everything for us and we are getting the single result. No, to that extent, it is not automated. All right, coming back to the discussion, these are different things which got updated into MLFlow. There are different features. MLFlow 1.11, what was added, 1.12, what was added, 1.13, what was added, right? So these are all the different things that we have. You can probably go through all this and then try to understand the updates, right? It's not really hard-coded. The documentation should be available. You don't have to by heart all this. As and how the product is getting matured, new features are getting added. Right? So you can probably follow through the change document and then understand how MLFlow has actually been upgraded. So this is with respect to tracking. Similarly, we will have the second module, which is the projects. And in projects, we basically try to generate the best model. I mean, you basically try to package everything and then make it ready. Package data science code in a format that enables reproducible runs on different platforms. So these are all the libraries that supports, and we will be able to use different platforms where we can try and package things. See, the packaging can be imagined as creating an image. How do we create an image in Docker? We will try and have an OS environment. Within that, we will have all the dependencies installed. And then we will have our actual code running on top of this. So that you just take entire piece and use as is in different hardware or different OS platforms. We are packaging everything, right? So projects is doing exactly that. It has dependencies also to be taken care of. All right, so it does that. Now, when we are running it, we can use different channels, and by default, the dependencies are captured using Conda channel. local execution or remote execution. It can be on Docker, Azure, right? Other platforms as well, cloud platforms as well. So it basically takes what code, I can say Python here, not R. Then we have configuration related details. We will have the data that is used. We have all the dependencies that is used. On top of all this, we will have the Python code executed. Right? So this is basically your project's details, and we are trying to trigger those packages anywhere, local or remote, cloud. And these are the 3 different environment channels that it supports. Conda_env basically is trying to capture your machine learning Python related libraries. Conda will be specifically used if you want using ML model deployment using MLFlow. If you have any other packages for OS related and other things, then we can use either Docker or system packages as well. Non-Python packages can be used, can be called in from Docker environment. So it's like requirements.txt. We are looking at what other things are required in order to run a machine learning model. And this is basically what you will see within the project. You'll have the project name or ID, and then the configuration files, the important Python files, the model files, the pickle file if required, right? All those things will be stored within this folder. This can be also on GitHub, and you will also be able to call the model from GitHub repository as well. Over internet, we can try and trigger the execution. You just pass the URL. And -p is the parameters. Either you can pass the command like this, or you can run like this, mlflow.run, and then do this. So there are different ways to trigger the job, and you'll get the artifacts that we can capture. All right. So packaging format, basically, it can be in local folder or GitHub repository. It basically captures all the dependencies. Right, and then it ensures that the code is run, and the code we can basically trigger the jobs in Python, R, Java, command line, right? All these things can be used for triggering your jobs. This is how the jobs can be triggered. MLflow space run. That's all. All you are going to do is MLflow run. The idea is to ensure that this code package can be run anywhere. Okay, so that's the idea. This is for remote execution. As I said, we will be using the link, the location where you have the GitHub code, and then the server that we want to run. We will pass the details, and then it's executed. Okay, so yeah, let me push it. So these are the phases. If you trigger your job, you'll say MLflow run. It captures all the details. It's like you're downloading the content and trying to ensure that the environment related packages, versions, right? All those things are updated, and you're basically having an environment which is ready with all those dependencies, right? It creates a environment, Conda environment, for example, and virtual environment, and within that, it ensures that all those things are ready. It also does the packaging of your dependencies using conda.yaml file. YAML is a configuration file, like XML. Yet another markup language, that is YAML. And even in Kubernetes, we use YAML files for configuration related things. And here as well, it uses YAML files. So it creates the YAML files, which defines the configuration of your machine learning. And then it can be used for running anywhere. So these are the steps that we have seen. So create the project, right? We define the entry points. Then we ensure that we create the Python code package with everything. This will then go into your configurations. So Conda YAML file will basically document the configurations. It records all the dependencies and everything. Right? And basically everything is getting packaged together, and you will have YAML file with the information. Then you will have a repository. You're going to push your project into that repository. And when you want to run that code, you can directly connect to that particular code repository and then trigger the MLflow run command. Right, so these are the phases. The idea is to have reproducibility, shareability, and flexibility. Reproduce means it can be run with different, it can be run on different environments. So development environment, test environment, production environment, but with it, the code should be able to reproduce in all these environments without any issues. And we should be able to rerun that, right? We should be able to experiment the executions as well. Then shareability, again, the point is the same. People will have different location or hardware requirements, code, software requirements, code repositories, etc. So the ML code that we are basically coming up with should be shareable. It is easy to share my code with you so that you can run it anywhere. What environment you will use, we don't know. So the code should also be flexible to execute it any different environments. These are the high level 3 points that we look at. It's in short, it is reproducibility that we are trying to look at. All right, so load, ETL, ML, and model training. This is the life cycle basically, and MLflow tries to take these independent steps and package them together. Okay, and this is how your code looks like. We'll see the code. Don't worry about the code. We'll see the code. And with respect to module 3, which is models, deploy machine learning models in diverse serving environments. So we have trained everything, we have packaged, but where do you deploy it? Right? So that is basically taken care by the models. Again, deployment can be anywhere. It could be on local machine or on cloud. Right? So we'll be able to support all of this. But MLflow models will also be able to tell which is the best model that you want to deploy. All you're doing is going into that folder, taking everything which is packaged by the project's phase and pushing that into your, or serving that into your environment, serving environment. So log model, save model, load model, and deploy model. Okay, so those are high level commands that we will be using. You can see here, this is a Keras model. So you'll have .h5 format as the saved model. Right? So that is under your data. Conda.yaml is the configuration details, configuration file, and you have ML model, which is used for building the model, right? That's the code. This code basically gave us the best model. Okay, so this is basically how you will see the content. So ML model, this is first run, this is second run. And depending on what model you are going to call in, you will have specific MLflow libraries that can be used. For example, here you can see MLflow.keras. That means this is Keras model that we are trying to train. MLflow Py function. This is more generic. You can use any of your Python function to execute your training job. But if you're using sklearn, for example, you can have this like, right, this model. So MLflow.py function is more like a generic command, and within that, in place of py function, you can put any of your libraries that you can prefer or you want. So that's basically your model space. The last one is model registry. This is basically to record. In short, it is a repository where you are recording what is the best model. Store, annotate, and manage models in a centralized repository. Because when we talk about development, you will have different developments. We don't know which one is basically the latest one or which one to be deployed and all that. So we will be able to define what is the best model that I want to deploy. You select a model and declare that it is deployable. So every team member that is using will know that, okay, this is the final model which I need to use for deployment. It could be a different team member also. If you have a UI provider, then they will be able to select. Right? So that's basically how your model registry works. It internally also takes care of CI/CD tools. It can incorporate with any CI/CD tools, or if you design your code in such a way that it is retraining, you can also use the same thing for your CI/CD implementation. Right? And it is a centralized repository control, which basically allows you to have the control over the executions on different models. You can see you have different versions. The stages are there. This is archive, this is staging, this is production. So version 3 is the model which is best model that needs to be put in the production environment. The remaining experiments are only experiments, they are not to be deployed. So you will be able to see this, right? All this comparison can be done. So register model, get the registered URI, or you can set it so that you can try and register that, or I mean, push that for your serving mode. These are all the commands for creating your models and all that. I mean, versions, specific versions. Okay. And everything is readily available in the artifacts and meta store. You can see it's there. All you do is load model, that's all, and give the artifact or the URI, model URI, which you define as the best model, and it takes all the details from that particular folder, and then it pushes. MLFlow helps you to push your best model into your production. Okay, so yeah, let's move on. There's not much of theory here. It is very high level theory. Now, in order to do this, everybody is using Anaconda. You are using Python, which is managed by Anaconda only.
Yeah.
Okay. So open Anaconda, and I will show how to create a new environment. You can use virtual environment if you are comfortable with that. Use virtual environment and proceed. But if you are not sure about the virtual environments and all that, then we can try and use the Anaconda platform to create another complete environment. Physically, it is going to get created. Within that environment, we will be installing MLFlow. So open Anaconda, Navigator. And here, if you see towards the left side, you see Environments tab. You click on that Environments tab. Once you click on the Environments tab, at the bottom, you will see create, clone, import, right? These options. By default, you will have base root. This is the only option you will have by default when you are installing Anaconda. This is the environment that you're using. But you can create as many environments as you wish. That means separate Python software gets installed, and Anaconda will allow you to manage those different Python instances. So I have created, I'll say create, click on create button. It will give you a pop-up like this. You can give name. I've used MLOps. And then you can see Python, packages Python. It is checked. Under the Python, you have different versions. Don't go to the latest version. Choose 3.8.15. I've not tested in 3.9, so I don't recommend that, but it should be supported. 3.10, that is 3.10, is something that I'm not sure of. I don't think it will work there, the latest of the versions. So my recommendation would be 3.8. Choose that version, right? And then you can say create. Right? It will give you this create option. You can see within Anaconda folder, there is another environment that is getting created. Okay, once you click submit, create, you will get this folder like that, with this name like this pop-up. Do it. It is going to take a little while. Once this is created, you click on, right? Once this is ready, you can go back to home. Under the home, you can see all applications on. The drop down shows base root. I select MLOps. So we are now trying to use the applications which are pinned with MLOps. Here, you can try and install Spider. It will first say install Spider, and then we will be able to launch it. So create an environment and then come to the applications or run on top of that environment and use Spider, launch it, install it and launch it. It will take some time. Just initiate it and you can then go for the break. We'll take a 10 minutes break and we'll come back at 10:55. It's 10:46 now. We'll take 10 minutes break and then come at 10:56. Yeah. Okay, so here we go to must topic, we go to MLFlow. And yeah, these are all the different okay, model registry should be there. Fine. MLFlow, ML project demo Python code. Let me see what is this. And okay, this is for your DBC file is for the Databricks. So we'll download the data. So MLFlow, ML project demo, Python code, and then datasets. Download these two first, 1 and 2. And this is what you get. Wind example.py. Once you unzip them, you'll get this. Yeah. Download it. You open this wine_example.py file in your Spider, which you have launched from this new environment. You have created a new environment. You come here. You ensure that all the applications on that new environment is selected. Install Spider and launch it. I'll show the code. I'll walk you through the code and then we will execute it. Very simple. It's I mean your regular ML code. So I'm importing all the libraries that are required. MLFlow. This is the package. Of course, we'll have to install it. I'll show how to install it, or otherwise we will try and install it and then come back to the discussion. Okay, come here to the Anaconda Navigator. Select the environments once again. Right, come here to the environments and select your model and the environment that you have selected. You see this green button, left click, don't do right click, do left click only. And you will see open terminal. Do this, open the terminal, it will open your command prompt. This command prompt should show that it is associated to this environment. Because when you do pip install, this pip install command should be applied onto this environment, not to the base root. So don't go to the command prompt directly from Windows. Open the command prompt from Anaconda Navigator environments page. Left click on this green button and then open the terminal. All you are doing is pip install MLFlow. That's all. You just say pip install MLFlow. Run it. It will take time, but run it. Once you have started, you can come back here to the code and I'll explain the code. So we are loading all the libraries that are required, including the MLFlow library. MLFlow sklearn, because that is the model that we are going to run now. In order to capture the metrics, we are writing custom function so that I can pass the actual values and the predicted values. And I will be able to
one second. Where is this wine example.py?
It's there in the LMS. In the LMS, you will have MLFlow topics. Here you will have one data set and then this code. Got it?
Is it under MLFlow underscore ML
Topics.
project underscore demo.ipy?
Yes, yes. This
Okay.
one, yes.
I mean, that
You
is same
unzip
as
that and you
the
get-
that is same as the Python file that you were explaining, right?
Yeah, it is the same thing. If I
Okay.
unzip this,
Because it named differently, so that's why I was.
it is in IPython notebook. You can open Jupyter. Okay, let's do one thing. Open Jupyter here under the environment. You see Jupyter notebook, right? You can just launch Jupyter notebook and open that. I thought it was a Python file, so nevertheless, let me just try upload here. Where is this file? I just uploaded it. Yeah. Oh, this is a different code, huh? Why is this code not updated? Oops. Wine quality, let me see wine quality. Great. Okay. The code is not shared. I'll share it. Let me share this code with you people. The IPython notebook is a different notebook altogether. Let's not do that. That's okay. You can ignore this. Good that you have brought this to the notice. I'll get this shared right away now with you people over WhatsApp. You can download it from WhatsApp, and I will get it updated into the LMS. There's other code also which was recently updated. I'll share that code as well.
You can't share through chat here in this.
Sometimes it doesn't work. So WhatsApp is a better option.
Okay.
Sometimes it works, sometimes it doesn't work. Right? So, don't know. I'll share it there also. It's not an issue. I'll just put that here. Data set you anyways have. This is the code. This is the first code. I shared it in the WhatsApp. Let me put it here also in the files. Where is this file? File from here. Not this. Yeah, I've shared in the Zoom as well. I get this updated to your LMS. Okay? The old stuff I'll get that removed and new stuff will be added. Open this file.
Yes. Yeah, I was able to open in Spider.
Yeah, it's a Spider file. Yes, please open that in Spider itself. I hope you have started the MLFlow installation here. Pip install MLFlow command is already executed, I'm assuming.
Yeah, that's done.
Okay, perfect. Okay, so let me explain the code. So we are basically trying to load the data. Import sys is not required if you are doing it on the Jupyter or Docker or right these things. It can be ignored. The other functions are important. We will be loading them. This line number 10, import MLFlow, if it fails when you are importing it, then restart the kernel. Okay, you can restart the kernel by going to the console page here and just say restart kernel, control plus dot, this symbol. It will automatically restart the kernel and then you will be able to load all these libraries once again. Okay, now post this, I'm defining the metrics for our regular machine learning models. Here, I'm trying to set experiment. When I say set experiment, I'm creating a new experiment with this name. So what happens is this will be like a execution that we are trying to define. And MLFlow will be able to track the execution as an experiment. Then we are moving ahead into the regular ML code. So this code is getting wrapped using this main function. Within that, we are writing your experiment details. Okay, so once the data is loaded within this, we will partition the data. We basically try and split it into input output. These are the parameters that we are going to pass for our model. The linear regression model I'm using is ElasticNet model here. So once these parameters are defined, we can come here and start the run. So define the experiment, and within the experiment, if you want to run the code, you want to, that is training jobs, right? When you are to train the job, you will be able to train the job using different parameter set, hyperparameter set. The hyperparameter set are defined here, right? So float, take the system arguments. If the arguments is greater than 1, then use it. Otherwise, choose default 0.5 or 0.6. All right, so that's the arguments that we are passing. And then we are trying to train the model, then use the model to predict on test data set. Then we are going to call the eval metrics, this custom function that we defined here, which will capture RMSE, mean absolute error, and then R squared values. Right, so these are the three things that it captures: root mean square error, mean absolute error, and then R squared. These three metrics are captured here for different alpha and different L1 ratio. Then we are also trying to capture these things in MLFlow. Till here, we are only recording or calculating the metrics by passing the different parameters. But here we are trying to capture these details. So log underscore parameters means it captures the parameters. These are the three parameters that we are capturing: the data partitioning size, the alpha value, the L1 ratio value. Then we have RMSE metrics. These are metrics that we are capturing: RMSE, R squared, and MAE. We are also trying to log the model. So whatever is the best model that we have got here, which is LR, I'm trying to save that as model. That's all. So this is the custom function that we are running.
Is this the part of storing the model artifacts? Sure.
Yes, this is to store the model artifacts with respect to each and every execution that we are doing, which will be part of the experiment. So you can just run this code, right? I've already loaded the models. I'll run this. This is a single function, so I'll select everything and then execute till here. Oh, sys is not defined. I've not imported this. I'll execute this. So once you execute this, you can execute it as a script also. You can just play this button. Everything is getting executed and it is capturing these metrics. Now, what happens is when you execute it in the current working directory, there will be a folder created called ML runs. Where is my current working directory? This is the current working directory. So I'll show you that. Under resources, I will have ML runs. This folder gets created. I'll delete this. I'll rerun this entire script. Okay, so it is getting created. Now you will see ML runs once again created here.
Can we set this directory to a location?
By default, it will be in the current working directory. Oh, okay. So this is my current working directory, this folder. So you have to set your current working directory. If you want to change the folder name, yeah, here it is getting recorded. It created today just now, 22nd Jan 11/12. Oh, it does. Yeah. Basically, these are the ML runs is the folder which is getting created. Now, what we do is go to that specific folder in the command prompt that you have opened. Okay, you can also say MLFlow UI here. Not sure if it works. Yeah, it doesn't work here. It's a function with command prompt function. So go to the location where you have this MLFlow ML runs folder is created. I'll select this path here. At the top, you can see in the spider, right? In that location, you can see that. I will just put that location. Here you will see that ML runs folder is there. Here you will say MLFlow UI. What is happening? Why is it removed? Import parameter source, import parameter source. Okay. Is it because of this D drive? It is because of my D drive, I guess. Okay, so we will do one thing. I'll change this to my current working directory under my executors. Why is this happening? It's going back to that folder. Okay, let me select this. Where is this option? Okay, let me go here. Under the session, we should have this feature. It's not shown. Crazy. Okay. Okay, anyways, this is selected now. Let me run this once again. Okay, it's again going back to that. Okay, we'll do one thing. Get import OS. I'll just do this. Import OS. os.get cwd. Let us see this. Yeah, this is in the folder. So what I'll do is I'll set the directory. os.set current working directory. And here I will keep the location as C:. Yes. I'll put this path as my current working directory. This is set directory. Working directory os.set wd. os.set working directory. CHDR, like that. Okay, so I have changed this directory to here. And let me just create. Is it creating ML runs folder for you people?
Yeah, I'm getting some import warnings and permission denial errors. So I'm
Warnings
working
is
on that.
The warnings is fine. Ignore the warnings.
I mean, the folder from where I'm actually reading the data that says it's not. I mean, permissions has not been granted. It says so. Maybe I need to run
Change
it as
that to a different location. Probably you have put it in Google this OneDrive or something. Maybe that is the reason.
okay.
So let me run this once again. I restarted the kernel and I'm executing it. It should actually by default create the ML runs folder. Yeah, it is created now. Okay. So let me now run MLFlow UI. Import Flask as Flask. What is this? Why are these errors coming up? From import command line. Why? This looks very strange. Okay, let me just check this error. Import cannot parameters click. Okay. Is it MLFlow? I don't think this is an MLFlow issue. Something to do with this package called black. Let me just try this. You're not getting any error? Are you guys getting any error or not?
For me, there were files created in that ML folder. I mean, I did not get any error.
UI, MLFlow space UI. Just do that. From the command prompt, you have to do it. The issue that I'm getting is with respect to a package called black. Not sure it's used for, but it's throwing an error. Click on black. Okay. And then install these two black. Okay, so let us try if this issue goes off now. Restart the kernel. Details. Okay. MLFlow evaluation metrics are captured, and here I'm just copying and executing this. Okay, I'm getting the folder. Yeah, see, 2 runs are executed. This is the YAML configuration file. These are 2 different executions because I have executed twice just now, right? So it's showing that there are 2 runs. MLFlow space UI. You give a URL. Yeah, now it is working. You should get this URL, and then you should be able to open this URL here. So if you look at this URL, it basically is a very simple interface that you can actually understand very easily and use it. You'll have experiments and models. We will first deal with experiments. Our experiment name is wine quality MLFlow. That is there defined here in the code. Start experiment, right? Experiment name is wine quality MLFlow. And within this, we have executed a run. So when you executed a run, you click on this, it will by default give some weird names. Don't worry about the names, but every execution will have a unique ID. Number you see run ID. If I go to this folder, you will see that run ID. E8702D, right? So this is the same folder. If I open the folder, you'll have artifacts, metrics, parameters, tags. Within the tags, we have not given anything. These are the default tags that it has captured. I have not specifically mentioned anything. Okay, it's by default capturing. Then the parameters we have selected. What parameters we have tried to capture here? The 3 parameters. One is the train test split proportion, alpha, and L1 ratio. So 3 parameters will be there: alpha, L1 ratio, train test split, proportion. Then we have also captured metrics, RMSE, MAE, and R squared. And then we've also tried to load the model, right? The name is model. So you will see load model. So it is logging everything that is required, pickle file, the requirements.txt. Then it is also talking about the YAML file. YAML file can be opened in a text file. This is the configuration. It's like your requirements.txt. Right? You have Docker file, if you remember, in Docker. This YAML file is very similar to the Docker file. This is the ML model that we have executed. This is the Conda environment page. So Conda Forge is the channel. From there, we are going to bring in these Python environment. Pip version is also given. Using pip, we are going to try and execute this. The execution name is MLFlow. All this can be seen here. So this is the folder run ID. These are the parameters. 3 parameters are there. The metrics. These 3 metrics are captured. Then tags, of course, it doesn't show anything because we have not specifically mentioned anything. Though it is captured, we have not mentioned any tags. Then this is the artifacts, whatever we have seen, right? So this is the ML model. Then conda.yaml. This is the model pickle file, the saved model. And this is your requirements details.
So the metrics will be different from different runs, right?
Yeah, these should change. These should change. So what we can do is come back to this. Now I have executed it twice. If I would have changed something and then re-executed it, it would have recorded something different. So I can basically do a comparison, select these and then say compare. You will be able to do the selection like this. L1 ratio, alpha, right? You want to compare all the 3 things. So these are same. Okay, but L1 ratio is little different for, I think so. L1 ratio is it different? No, it is the same, I guess. R squared, yeah, MAP and R squared, we are able to capture. The L1 ratio is same for both of them. These are the metrics. You can also use scatter plot here. Box plot. You can select what should be there on x-axis and what should be there on y-axis. You get the box plot details. And this is contour plot. Contour plot is like a 3D visualization, area visualization. Now we don't have many runs, so it's not showing much details here. If you scroll down, this is first section is visualizations. If you scroll down, you see run details. So comparison, it is trying to give you the comparison when it was run, when it did complete, right? What is the unique ID and all that. Then we have parameters. You can select this to show only the differences because we have not changed anything. It's just a rerun of the same code. There is no changes. But look at the metrics. The metrics are changing because the proportion that we have defined is same, but the train and test data, because it is randomly selecting, the metrics will change.
Yeah, it's like due to cross validation, right? So different train and test.
Yeah, we are using train test split, right? So it is randomly selecting the training data and test data. So it gives us the different metrics. You can just select this, so it will captures what metrics are different. If you have any, right? Same metrics, then it will ignore that. So it's basically used for comparison purposes. Are you able to see this?
Yes. So we have the model registry here, right? So what about the data registry? What if the new data comes in? Where are those artifacts stored in this?
No, we are not talking about data related things here. This is primarily with respect to the model and what data features we've used for that model. Those things can be captured. That's all. It doesn't store the data as is. If you keep storing the data, it is obviously going to become a very big application and it requires a lot of storage space and all that. It doesn't require that. I mean, it doesn't store that.
No, what I'm talking is, what if the new data comes in and we are training on the new data, right? So where are those details stored? Like we also need to keep track of on what data we are storing, right? I mean, on what data we are performing the modeling, right?
No, that's what I'm saying. It doesn't capture the data details. It only captures the model details and model respective metadata.
Oh, okay.
If you're rerunning the model, then as per that model execution, it captures all the metrics and all those things. Then you will be able to see that there is a drift. Now, if you know that there is a drift, that means something is changed. What is that changed? We will go back and check the data. Data drift is something that this is not capturing. Remember, we are talking about only 4 aspects: tracking, projects, models, and model registry. Nowhere it is talking about data.
So we cannot be able to recognize the data drift using MLFlow?
No, what you can do is you can write a model analytics model, which captures the EDA results and all that, and you can capture those metrics as well. That way you will be able to do the comparison.
Okay.
Okay, so this is the first execution, friends, and I will share another set of code with you people. Let me check where is the code. Now this is for MLFlow and credit data set. Credit data set could be a larger data set. Let me see if I can share that over WhatsApp and or here. It's a challenge. Let's try. What's okay. Let's try. Oh yeah, great. Data set is not, we are not able to copy the data set. Oh, God. Okay. 143. Let me see if I can share that in the Zoom itself. Data. I'm trying to push it in the, oh, okay, it is uploading. The file, dataset file is 143.84 MB. So over WhatsApp, I'm not able to share that. Here in the Zoom, I'm trying to share it. It's almost 50% loaded.
I haven't received any previous data through Zoom, should I?
The previous Wine dataset is there directly here. The LMS itself, you can download the Wine's dataset. Yeah, try and download now the credit card.csv file, which is shared in Zoom.
Where did you share in Zoom? I couldn't see anything here. I didn't receive anything.
Okay. It's not showing yet in that case.
You can't upload in the LMS right now?
I cannot do that. We need to, I'll check with the team. Let me explain the code and the data, the flow of the model. Let me in the meantime also check with the backend team. Probably they will, it takes some time to upload because it's a complex system in the backend and I don't have the permissions. I don't have access to the backend system. I'll not be able to do it. Yeah. Okay. Just take a couple of minutes break. 2 minutes break. Let me check with the backend team if they're Sunday, right? If they're available, I'll just ask them to upload it immediately. Just give me a break. 2 minutes. Yeah, guys, I've shared the information with the backend team. Okay, I received the call. One more minute. Yeah, it is done, friends. I've informed the backend team that they're doing it now. So let me proceed and talk about what we are supposed to do. Once they have updated, they will confirm, probably 10-15 minutes. And once they are done, we will you'll also be able to download and do it. Okay, so I've asked unnecessary things to be removed as well. So let me explain the code that you are going to get now. This model. Yeah, this MLFlow.py, which I have already shared over WhatsApp and over here. You can open this file. This file basically is explaining us how to run hyperparameter tuning and then choose the best model. And then we will also be able to save that best model for deployment. We're not just doing the deployment, but the rest everything is being done here. Deployment, we will do it on Azure platform. Okay, so additional code is also given. If you want to run through this code, you can also run through this additional code. But till here, we have the code which is required. So let us go through this. So let me clean it up. All the libraries that are required, we are basically importing all of them. NumPy, Pandas, Matplotlib, Seaborn, sklearn, related things. MLFlow and MLFlow sklearn. Again, I'm using sklearn version only. You can check what are the various versions that we are imported. I've not imported this. So these are all the different versions that we are using. MLFlow is 2.1.4. Next, we are importing the data set credits.csv. I'm defining the path and loading the data set. This is not that way. Copy as path. I'll just update this here. Okay. So I've changed the path here to point to the directory where the file is placed. I'm loading the data set. I'm calling it as data. Now this data set is a large data set. It contains 4,898 rows and 12 columns. And out of these 12 columns, if I say info, all the columns are float data set, float values, except the last one, which is the class. This class is your output variable. The data set is credit card transactions data set. We are saying whether the transactions are genuine transactions or fraud transactions. Just an example data that we're taking. In this, time is not required. It should be a string, but here it is showing us float. So time is not required. We can delete the time. If you want to see the data set, you can just double click this and see the data. Spider is unable to retrieve the value of this format in the console. Oh, why? Strange. Let me say head. Okay. Here it is coming. So you can see time is in some weird format. We will be deleting that here. And then again, you can say head. You will be able to see the data without the file. Something is happening. Then the class that we have, right? The class data that we have is basically numeric data. Okay. So some issue. Look at that. Data set size, it has not loaded completely. Give me a second. Okay. I've imported the libraries. I'm loading the data set. It should have, now it has loaded the full data set. Okay. I'm removing the time and I'm saying head. Now I'm getting the complete data. Value underscore counts, it basically gives us the breakup. How many genuine transactions are there? How many fraud transactions are there? Now what we're doing is just to ensure that our example code, right? This is an example code. So in order to ensure that our example code doesn't get bogged down because of the dataset size, we are trying to take only a sample of the dataset. So here you have 28,000 records, right? Not 28,000. This is 200. What is this? 284,000. Here, if you see, genuine case transactions are 284,315 transactions. It's a very large data set. So what I'll do is I'll take only 50% of this data. Okay, that's here, defining here. So take the data from class equals to 0. That means these number of cases that we have, right? Take only 50% of the data and reset that index. Don't use the same index, reset the index. This way, I'm trying to reduce my total dataset size to a smaller dataset size. You can see here from 284,000, now I have 142,000. And for anomaly dataset, I have only very limited number of records. So I'll take those records as is. 492 records. Okay, this is the shape of your dataset. You can cross-check. Next is I'm partitioning my dataset into 3 parts. One is the train. The other one is the validation data. So first I'll do train test. Using train test, I'll say train and test. right? This is 20% of overall data, and this is 80% of the overall data. Now, this training data set is further getting split into train and validation. So I'll have data set 1, data set 2, data set 3. Right? So load the data set, remove the unwanted time column, take sample data set only from the class 0 so that the data set size is not too much of imbalanced. Then we are splitting the data. So first split the data into train and test for normal data and then anomaly data. That means 0 class and 1 class. Then this data set can be further split into train and validation. Right? So train, test, and validation. 3 different data sets have been captured for 0 class and 1 class. I'm splitting that data into the input and output separately for all the 3: training data set, test data set, validation data set. Okay. So I have train input, train output, validation input, validation output, test input, test output. Right? Three parts we have captured. Then you can see the sizes. These are the respective sizes of your data set. Train data set, test data set, validation data set. Then we are doing the pre-processing. Scalar, I'm using the standard scalar. I'm applying the standard scalar model to the data set, input data set, except for the class. And I'm transforming this on the 3 data sets: train, test, and validate. Right? So doing in your standardization, so that the scale of all the input columns is. Next is I'm trying to define the custom function called train. This is to define the training of the model on the training data set, and we will also be able to score the data on the training data set. We are capturing those metrics. MLFlow.log metric. So when you train your model on the training data set using this model that we are defining, you will be able to train and then record the scores. Then for evaluation, we are using the same SK model, but this time I'm using test data set and evaluating the model. And these are all the different metrics that we are capturing, and visualizations are also being done. Right? We are saving the figure as well. These are the metrics that we want to capture. Using MLFlow, we are only capturing the evaluation score and accuracy score. All right, next. This is where I'm defining my model. So let me run this. I've not run this. Define the custom function. This is the logistic regression model. I'm developing this using solver, max iteration, and random state. These 3 default parameters I'm using. Once the model is defined here I'm starting the experiment. Just say MLFlow.set experiment and run this. Now what happens is in your MLFlow UI, you will be able to see, it's not started yet, but you will be able to see this one. Yeah, sklearn experiment 1. I've just started the experiment. Now within this, I'm going to run the model for the first time. So train, I'm calling the custom function, passing the SK model, train data, test data, train input and output. Then I'm doing evaluation and then recording the model. This is the first run. Start run, end run. Now again, we'll go to the MLFlow and see. If I come here inside it, you will be able to see this model. If I click into this, you will have artifacts and all that captured. The images are also there because our code was selecting the images and capturing those images. Right? These are the images which are also getting captured. In MLFlow also, we are capturing that. These are the parameters. I have not captured any parameters. We have metrics that we have captured. Right. So this is the first execution. I have not captured any parameters. We are only capturing metrics. 3 metrics we are capturing, right? So only those 3 metrics are captured. We can rerun this model once again. This time you can again use an experiment. You don't need to do this. But if you have to map your model, then you are going to map the model like this. Now, what we are doing here is we are not trying to rerun the model. We are trying to load the model. Okay, this is version 1 model only. Sorry, version 1 model loading. So here I have loaded, experimented. Here we are going to take that model, set this experiment, and within this experiment, log the model. Yeah, so this model, we are logging it. So it will be called now as, sorry, this is version 2. This will be called as log regression model. So let us go here once again. So this is logging the model. This is just now we have executed. This is the model. The folder that the logged model is this folder. You can see log regression model. So it will create that folder name. ML runs. Here we have what is the ID? Let me show you. UI 38B95. 38B95. If I go to the folder, yeah, this is the model. Now, what we have done is we have logged the model. Right. That means you should be able to see this model logged into the models folder. It's not coming. We have not registered it, right? We just logged the model. We need to register the model and log it, of course. But yeah, what we have done is we've logged the model. So it is creating this folder, right? And this folder is basically getting, how do I say? We are basically saying that, okay, this is the model that you might want to now use or register. Okay, we are logging that model. Okay, and we are activating the model run, and you have these details printed here. When you run this, print function is executed, and you will be able to see the result as well. What is the run ID is something that you'll be able to see. Okay, so let me run this. This is the run ID. When I executed everything at one go, you basically will be seeing everything printed, and your machine learning function will be stopped here, and this is the version. Okay. So here we have logged the first model. Here we are logging the second model. 2 models we have logged. Now, among these 2 models, I will be able to try and register and then deploy it. Now, what we have done is running a single execution. What if I have to do hyperparameter tuning? So if I have to run through the hyperparameter tuning, then let us try and use it. But yeah, that is the second experiment. Let me finish this. So load model, log model is to register or to save that artifacts into the MLFlow ML runs folder file store. Whereas here, if you see, we are loading an MLFlow model and then executing the results using that model. But this folder has to be changed. This is the run ID that I have to give here. So when we executed this, it is giving us run ID, right? So just change that folder name. So we want to load the model, but what model you want to load, you have to give that location, and we are calling this as log regression model, right? So we are giving that name as well. So when I do that, I get the linear regression model, which is trained here. Using that, I will try and do the prediction. on the test data set, if I'm testing it, how does it work? It is giving us 99.87% accuracy. All right, so this is basically how we do the training and loading. Now, if I have to do hyperparameter optimization, then this is the code. First, I'm defining hyperparameters. I'm saying anomaly weights is 4 different options. Then I'm saying number folds is equals to 5 because I'm going to use k-fold model here with k is equals to 5 and trying to run the k-fold validation. These are the hyperparameter set that we are going to use. So 4 into 5, 20 different iterations have to happen. Hyperparameter tuning. Now to do this, I'm going to use a different experiment so that I know the difference here. So if I click on experiments, you can see experiment 1, and this is the previous experiment that we have run. Let us define this. So the folder is not there. Now there is a folder created and there is this particular tag name also created. Right? Now within this, I'll create logs folder, empty folder, empty list, sorry. And then I'm creating a for loop in order to run the iterations 20 times and record those details. So this is fold 1, weight 1, fold 2, then we will have fold 3, fold 4, fold 5. K4, 5 times it runs, right? K number of times it runs the execution for the same parameter. After this, the weight will change and we go back to fold 1, weight 5 now. If you come here and if you click on this, you can see that it is recording these details. Every execution that is happening is getting recorded into this particular system. So total 20 records will be there in that particular MLFlow. So this is how we do hyperparameter tuning, isn't it? We pass the parameters and we expect the model to automatically trigger those executions and then record all the metrics. Any errors in your systems, let me know. No, you don't have data sets, sorry, my bad. Let me just check. Yeah, just check now if you're able to have the data.
Yeah, sure. I was able to download the data, but I haven't run yet.
Ah, okay. But LMS, it's there, right? Updated.
Yeah.
Oh, great. Yeah. And a single thing is that you can download everything which we will be using in our class now. Great. Yeah, so done. So total 20 executions it has run. Depending on the number of parameters you are going to define here, those many times it will run. And here we have captured these different models, 20 different models. Now you want to do the comparison. Select all the models and say compare. This is how you are going to compare all these metrics, parameters, and all that. And you scroll down, these are the executions. Now, if you want to see out of all these 20 runs, which is the best model, then choose one of these metrics. I will say accuracy score, AUC score or accuracy score. I'll select this and I'll be able to compare all the 20 models, AUC score, accuracy. You can also see here the 20 results, 20 models results. And I'm interested in getting the maximum. So this is the model which is giving us the best result. Now, what is this model? This is the model. If you select that, it goes into that. Basically, it is weight 5 fold 2. That's the execution which is giving us the best result. Anomaly weight is 5 and execution is fold 5, fold 2. And these are the accuracy metrics that we have. So among all those 20 runs, what is the best one? We will be able to identify. We have the run ID, we have the folder name, right? We can directly go to the folder, copy all these, right? We can also manually do all these things. Now you can register this as the best model by clicking here, the UI. It's very simple. Just click on it and you'll be able to register. But before that, you need to create a model here. Say create a model, give a name, right? And then go back to the experiments, the best experiment that we have identified. There you can say register model. Map that model there with the UI. Or come here. We will first do all those search and all those things that we have done in the code now. I want to identify the best model based on the accuracy score. So I'm ordering these results, metrics based on the accuracy score in decreasing order, and I'm choosing the first one. Decreasing order means the highest will be at the top. So this becomes our best run. Best run, it contains all these details. So you have run ID. Right? You can cross-check. This is your best model. I'll just do the comparison. I'll directly go to the accuracy score and then arrange this in decreasing order. And this is the. This should be your best model. E17, E60636, right? So that is the same ID. Unique. So we have successfully identified what is the best models, run ID, and what is the accuracy. Okay, run ID is captured, accuracy is captured. This is the run. These are the entire details of that particular model that we have captured. Using the model history, log history. This is one of the tags that you have here. Model log history, right? So it captures all the details. So when you click on that specific link, you will be able to get all these details. I wanted to understand what is this particular run. In K-fold, what is that K-fold that we are giving us, which is giving us the best result? So this is fold 2. So I want to register this as the best model. So I'm going to give that exact location, which is my best model. So till here, you will get the artifacts. Best run, run ID. If you give the run ID, it goes to the folder, which is E17. This one. It goes into this folder till here. But inside that, we have another folder, which is anon wait 542. So that folder is given here. I'm adding that folder also. But to identify this name, we are trying to capture these details. And this becomes your best model. I'm registering this using the register_model function. When I do this, it creates a model here. Best log model. What you can do is you can create example model. And I'll give a name. That's all. Okay, I'm giving a name here. And if I come here, I will be able to select anything. I'll just randomly select one thing and I'll say register. Which model I want to get? These are the models that I've created. If you don't have a create model option there, you can click here as well. Select this and register. So this model becomes your registered model. Here you will be able to see the details. By default, it is version 1. Right? If you make any changes to your best model and register it again in the same model, then this becomes version 2. You'll also be able to mark whether this is staging or whether this is production model. We'll be able to give those details as well. Now to do that, I'm using MLFlow client. This is another package that or function that I will use in MLFlow to capture the versioning, define the staging, right? All those things. So client transition model version stage, I'm defining this as production. This is the name. I'm capturing the version and I'm saying, hey, this is your staged production-based model. If you just do that, you can see version 1. So this model, we have defined it as production stage model. Stage is production. Now I'm using that specific model to be loaded. Here it is runs, but here it is models. So you'll also see in the ML folder, there will be a folder called models. Within these models, you will have the models that we created. This is the best model. This is the version 1. The metadata file is given here. This is your metadata. Why is it open up? Let me close this. I'll open it in a text file. It will be easy for you to understand. This is the ML configuration details, which basically says what is the source from which we are creating this best model. Configuration. Okay, so metadata is also given here. This is meta. Metadata of your model, which is selected as the best model. All right. So we will be able to get this information from UI as well. Now, once this model is loaded and printed with respect to the accuracy. So I'm basically trying to do the prediction on test data set, and this best model is giving me 88% accuracy. Now, if you want to use this model for deploying or embedding it into a UI space, then MLFlow will have the capacity. It can be configured using Docker, it can be configured using Kubernetes and all that. And then we can push this best model, which is mentioned as production, for serving purpose. All right. We can also do that, or you can directly come to this folder, copy this best model. Right? I mean, take these details and go to that specific folder. This is version 1, right? Where is our best model located? This one. So you go to this particular folder, copy entire thing, and then use that on your edge device, or probably your endpoint creation server. Whatever is your server, right? You basically put the entire data there. So all I'll do is I'll take this folder, copy everything and zip it and then put it there. Or I can just take this particular content and then push that into a Docker image, and then I can also run that on the Kubernetes engine. So it becomes very easy for you to manage your machine learning models with MLFlow. Questions? Is it easy compared to Kubeflow? This is very easy, of course.
Yes, sir. Regarding a deployment, when you are saying that we can push this data to Kubernetes or Dockers, it has to be done manually?
Yeah, you're having the code, right? This code YAML and Conda YAML and all those things are there. You can create an image. How do you create image? In the Docker command, we have a command, right? Build image, build command.
Yeah, but through the UI, can we do it?
No, you need, from here, you'll not be able to do. You need to configure it with Docker and all that. So we will be doing that in, let's say, for example, we are running the same example, not same example, but other example, which has Flask code also along with it on Azure. In Azure, you have those additional things also there, which basically is compatible to your hardware, and then we will be able to deploy that. The code that we have developed here, it does not have Flask applications and all that for creating UI and all those things, right? So what we are going to do is we are going to run the another example, this one, this code. This code has basically the Flask application and all that, cars1.ipython notebook, right? We will use this. Of course, this is also, we don't have Flask. Sorry, I said Flask, but it doesn't have Flask. But we will use this particular code for deploy. Now, when you say deploy, what happens is the best model. So you have best model. like what we have seen just now, we select the best model. Assume this is your best model. So we get the requirements.txt, we get the actual code, right? Now we will upload this into Azure, because Azure has hardware that we can take advantage of. We can leverage the hardware, right? So once your model is identified using MLFlow, we will do deployment. Now, when you say deploy, it needs a hardware to create endpoint. Now, here we cannot do that. We can do it. It's not that we cannot do it on here, but hardware resources are not available here, right? You again have to do it on local machine. So when you do this deployment on Azure, it becomes very easy. You will get a dedicated environment for creating your endpoint. I will show you that. From here also we can do it, but it's a little tricky on local machine. Okay. So are you running on local machines, or are you running this ML models on cloud? Where are you running your machine learning models?
Currently, I'm running on local.
Okay. Local means your regular laptop.
Yes, yes.
Okay. But do you have Kubernetes, Docker, and all those things also being used on local machine? Kubernetes, I don't think you'll be doing it on local machine. Correct me if I'm wrong. If you're using Minikube, you'll be able to do it, but otherwise, you're not experimenting on local machine, right? For your official purpose, I'm talking about.
No. So for learning, whatever you're teaching us in class, I'm currently executing on local, and whatever you performed on cloud, that I try to do it on cloud.
See, ultimately, when you talk about official purposes, it will be on cloud. Local machines will only be doing it from a training perspective or experiment perspective. One-off cases and all those things. Once it is ready, you will have to take it to the cloud platform. What cloud you're using in your organization?
AWS.
AWS. Yeah. So deployment on Azure becomes easy. Using MLFlow, it is easy because everything is being tracked by MLFlow itself. All you have to do is select the best model and say deploy. That's all. Right, and it will map the endpoint based on the hardware that we are providing, and then it gives you the interface. If you have a Flask applications and all those things scheduled, it will also give you the Flask application UI, like Kubernetes, right? What we have seen in Kubernetes. Ultimately, it is going to map. It is going to take Kubernetes hardware on. Okay, so this model, whatever we have selected, is going to either sit on a single server, this is standalone server, or it is going to sit on a Kubernetes cluster. Depending on how you're designing your ML code, you will be able to use the hardware appropriately and then create the endpoint. In our code, we are not using Flask, but you can take the Kubernetes engine example that we have run and try to deploy that on Azure using the same process that we are going to run through. Not now, I think we don't have much time now left out. So we'll push that to the next week. Practice on the local machine with respect to MLFlow for now. So in the next class, we will talk about how MLFlow's is used along with Azure to deploy. Okay, and then we will also talk about TFX.
Sharath, can we take some image data next class?
Yeah, next class I will talk about image only. I have the image data. I will making small changes to that, so that some sensitive data is removed and so that. So those things I'll make changes and I'll do that. So it's the same thing. Whatever we have done here, ultimately what we do, a machine learning model will be trained, tested, and saved. But it depends on the data that what we are passing. So you'll not see much difference. It's just that the input data will be image data now. That's all. So I'll show that. In the next class, we will do that.
Sharath, I have one more question. So there is something called feature store, right? That in MLOps we can also include while modeling. So are we implementing that feature store here as well in MLFlow?
It's already there, right? Feature store is nothing but your folder. Artifact store and feature store are nothing but these folders that are getting created. We are talking about MLflow related document that you have seen, right? In the presentations, we have seen that stores, meta store database and all that. You're talking about that only, right?
No, the feature store is the one that I'm talking about is when we have like a bunch of features. Say, for suppose we are doing EDA and finding out what are the most prominent features that are impacting the target variable, and those features will be changing as and when the new data or the model parameters changes, right? Yeah.
That becomes part of your code, right? Say, for example, in our code, in this code, the previous code or this code, I don't remember. Yeah, in this code, we are saving these results. Log artifacts, if you go to the MLflow, any experiment, if I go there, where is this experiment? Yeah, in this experiment. It is also capturing the images, right? You can see these images. So what you're going to do is you write your code, ML code in such a way that you load the data, you do feature engineering or feature importance, for example. Feature importance plus. Now you log that as your metric. Then you will be able to see that result as well. So it is part of your ML code that we are going to utilize here. So MLflow will capture these things: parameters, metrics, and artifacts. You have to use these capacities to manage. You also record the feature details. So when you're talking about, let's say, metrics, you're going to say, as part of your EDA, you're going to record the minimum, maximum of X1. So first execution, I'll say, is experiment 1 or model 1. For X1, what is the minimum and maximum? What for X2, what is minimum and maximum? So you're going to record these artifacts or these metrics for all the metrics that you have. Say, for example, 10 columns you have, all the features, you're capturing these details. You're also capturing, let's say, mean, standard deviation. This is your basic EDA parts you're capturing. Now, when you're basically rerunning this model, and if you have new data coming in your model, you're going to pass, let's say, data 2, version 2. Then based on the version 2, you're also going to get, all these metrics captured once again for version 2. So this is model 1 execution. This is model 2 version execution. Or I should say run 1 and run 2. Rather than model, I would say run 1 and run 2. Now I will be able to compare the differences between run 1 data and run 2 data. using these metrics that we have captured. So it depends on how you're writing your code, what parameters you're capturing, what metrics you're capturing. Once you're able to design that code, then you will be able to come here to MLFlow and then do the comparison. Like this, you will be capturing. For multiple executions, you will be able to capture like this. You will simply do select and then say compare. Once you compare, you'll be able to compare the metrics. So for different executions, you will be able to see the metrics. That comparison we have observed here. Right, metrics, you can see different executions with comparisons. Make sense?
Yeah.
All right. Okay, any questions? Any more questions?
Sharad, do we also have like any documentation regarding implementing the Kubernetes on AWS? So that one was given as an assignment to us, right?
Same thing, right? Official documentation only. You can go to the official documentation and just follow the official documentation.
Okay.
See, all these things are open source. Okay. And we can basically go to the Kubernetes.io. This is the right official website. You can click on documentation and you can start with respect to, you can say try Minikube, or you can install Kubernetes. Where is this installation? Yeah, install kubectl. Okay. Online Express Cloud. Let me just search. Deleting document is available, so we can just search for this. This is support. Okay, let me do one thing about this. I'll directly come here in Google and search for Kubernetes installation on AWS. Yeah, AWS documentation is available. This is also. Yeah, installing Kubernetes with KOps. Kubernetes on AWS. All right.
Yep. I thought, I mean, you have something in our LMS, like the way you uploaded the commands that we used on GCP, right? So I thought you already have some
official documentation. That documentation that I have given is also from official documentation.
Oh.
Yeah, Jupyter.org. Here also there are a lot of documentations are there. You don't have to rely on one specific documentation, and don't stick to one documentation, because these are open source tools and they constantly get updated. Yesterday, when I was speaking with respect to Kubeflow, also I was specifically saying that don't rely on the documentation which is given in the LMS, because after a few days it might change. Few months, the documentation might completely change. Yeah, so that's the challenge. We cannot rely it on that. And these are readily available services, friends. AWS and right, all these things, right? Azure or GCP, if you talk about, these are all readily available solutions. Okay, if you want to use Minikube, then Minikube, then okay, we can think of it. But if we talk about Kubernetes on AWS, then you have that KOps. You can also have this official documentation given by AWS itself, we call them as EKS. What is Amazon EKS? Elastic Kubernetes Service. You directly register for this and kickstart the service. That's all you have done. You'll get the Kubernetes cluster. Like we have AKS, right? Azure Kubernetes Service, GKE, Google Kubernetes Engine. Similarly, we call it as EKS. All right. Yeah. Any other question?
Sharath, I have a generic question. I mean, recently we are hearing about the ChatGPT buzz and all, right? So
Yeah.
they're saying that that the manual intervention of jobs and everything will be reduced, and how. I mean, can you shed some knowledge on how it is going to impact on AI and what areas should we target going forward?
Okay. See, that's I should say it's more of a hoax rather than the reality. It takes time. I mean, we are not in a fantasy world like Terminator movies are showing. Everything is like automatically done. Those things are probably at least in another decade we'll not see that. Not even
Okay.
decade, our lifetime. Sorry. The point is, these tools are basically helping the developers or helping people. Right? The machines are helping people. But in order to design those applications, we need people. It's not like you cannot completely remove humans. See, if you want to run a Python code, you can ask a AI model. I mean, ChatGPT can help you write the code. So it is helping a person to write a code. But what code to write? It cannot imagine itself. That's it. That we need still people who are logically required to define what action the AI system has to do and control that. And I mean, you need to still deploy, maintain the ChatGPT, improve the ChatGPT from its accuracy purpose, from a training perspective. A lot of things have to be done yet. So it's not that jobs are cut on all that. No, it's just that more smarter and smarter people are going to get jobs. If you're not going to upskill yourself with all these latest of the technologies, then you're going to be left out in the race. That's how it is. We have to live with the technology. There's no other option.
Okay.
My take. You should not be really worried about it. That's my take. You just ensure that what is latest in the market, try to learn about that. Simple. Yeah.
I also have I don't know about India, but in US the data science market is pretty unstable right now, right? Like if they are actually willing to lay off anyone, like first ones they are going to cut our data scientists or ML engineers. So
Because too many people.
yeah.
But how about data
So
engineering? Data engineering market or ML
yeah, data
ops
engineering. Yeah, there are like so many jobs of data engineering, like especially like Azure data engineering and AWS.
Mm-hmm.
The requirement
Yeah.
is a lot.
Yeah, because see, what happens is, as a machine learning expert or a data scientist, you will be writing your machine learning model, right? You'll be doing experimentations. You will be writing multiple, probably experimentation. Thanks to this ML, auto ML libraries now, everything is being automated. So you run one script, and then all the ML executions are automatically happening. But in order for that data scientist to run through that, I mean, come to that level, data is required. Right? And data is constantly getting generated in different forms and different things, and all those things are coming into the picture. So data engineers are being required now because data scientists have already developed and kept the models ready on sample data. But data engineers will be required to ensure that this model is getting constantly fed with the data. And ML ops engineers are required for ensuring that this model, which data scientists have developed, is running to the customer satisfaction levels. Right? So All this while the industry was focusing on the center area, which is data scientists. Now they are focusing more on the edges, data engineers and MLOps. Slowly the focus area is drifting from center to the boundaries.
So data sciences is no more a fancy
No,
kind
no,
of
no,
a
no.
job.
I will not say no. That's a wrong statement. That data scientists are required. But what industries are looking at is, I want a single resource who can do everything end to end. I don't want different people to manage my project. That's the aspect now, right now in the industry, because I don't want to pay 3 different salaries. I'll pay one single salary, probably a little higher salary than one individual person. But that one person knows what is happening end to end. So the quality of the product will also be better. The requirements and all those things will be captured in a single instance in a way which is required for developing end-to-end solution. If you have 3 different people, the quality comes down because the communication gap happens. One person doesn't know what is happening with the other person. So there's a complete chaotic situation. So industry has realized that, and they're saying, if you're a data scientist, if you know how to deploy, okay, come on. But if you are a data scientist and if you say only I'll develop machine learning models, then sorry, I can get that done using any of the cloud platforms or any of your readily available auto ML solutions, and I can hire one junior resource who can do that. Because all these people who have invested their time, money, energy, they have automated things. Right? So that's how the industry is moving. So be a data scientist, but ensure that end-to-end everything is understood.
Sharath, after TFX, what else do we have to cover? Are we also covering Apache Airflow?
Yeah, within the TFX, we will be covering Apache Airflow. That would be our last topic.
Okay.
TFX is the last topic. Within that, we have Airflow.
Okay.
All right. So we will wrap up the session for the day, and we will connect next week, and we'll look into the Azure implementation and then TFX. Thank you, guys.
Thanks, Sharath.
Thanks, Sharath. Thank you.
Yeah.